Number 1. Evaluate the following probabilities based on the standard normal distribution. A. The probability that z is less than 2.51. So what's happening here is we have a normal distribution. So if you draw a bell curve, and note that on the standard normal distribution, the center is located at 0. Z-scores that are to the right of 0 are positive, and to the left of 0 are negative. So 2.51 might be somewhere over here. So essentially, all the values that are less than 2.51, that's the total area that I want to find for this normal distribution curve. All right, now let me draw this a little bit nicer. Okay, so 2.51, you can see right here between, halfway between 2 and 3 basically. And what I want to do is find the total area under this bell curve from negative infinity up to 2.51. Now, we can't use negative infinity on the calculator, so recall that you need to use something to represent negative infinity. Negative 10 is small enough in terms of z-scores, and so what we would do is calculate normal CDF, negative 10 up to 2.51, and that would get all the area to the left. So doing that, we would do second distribution menu, normal CDF, negative 10 to 2.51, and our answer is 0.9940 to 4 decimal places. Part B, the probability that z is greater than 1.61. Again, let me draw a distribution. Okay, so I've drawn the distribution, and I've noted approximately where 1.61 might lie on my scale. But the area that's shaded now is to the right of 1.61 because it's z greater than 1.61. So I need to go from 1.61 up to positive infinity, which, like last time, we'll just use positive 10. So on the calculator, I'll use the function normal CDF, because that's the function that finds the area underneath the normal distribution curve. 1.61, comma 10. And let's try that on the calculator. Normal CDF, 1.61, comma 10. And we get 0.0537 to 4 decimal places. Part C, find the probability that z is between negative 0.25 and 1.44. So if I were to sketch what this looks like, here's what I would get. So negative 0.25 is just a little bit below 0. And 1.44 is right about here. To get the area between, we just use the lower and upper values in the normal CDF function as what's provided. So normal CDF, negative 0.25, comma 1.44, and put that into the calculator and we'll get our answer. So second distribution, normal CDF, negative 0.25, comma 1.44. So 0.5238. D, find the probability that z is greater than negative 0.61. Again, let me pull up a sketch. And obviously your sketches don't have to look anywhere near as nice as the sketches I'm putting on screen. It's just I try and make things look as nice as possible when recording. But as long as you have the pertinent information, like where negative 0.61 is approximately, okay, and it's going to go from there up to positive infinity, but again, we'll represent positive infinity with positive 10. So we would use the function normal CDF and go from negative 0.61 up to positive 10. And let's see what we come up with. So second distribution, normal CDF from negative 0.61, comma 10, 0.7291.